Let's play a little bit with the saturation of the image. I have purposely chosen very colorful image, and we will first try to desaturate this a little bit. Which effect should we choose? The most logical choice would be to use the hue saturation value, drop it here, and simply lower the saturation, right? It is less colorful, but at the same time something weird has happened to the overall feeling of the brightness of this image. Let's quickly compare the original with this one, and it seems that we lost a little bit of the contrast and it doesn't feel okay. Let's set the saturation to 0. Something is definitely wrong here. Okay, let's compare this image to the original image passed through the converter RGB to black and white node. This node converts the colorful image to black and white image. So let's simply connect this image here and take a look at the result. This feels much better. So this is the desaturated image, and this is colorful image converted to black and white. When we compare this one to the original, let's switch between the two, and we can feel that we are looking at the same image, but this one is colorful and this one is simply black and white. The feeling of the brightness is exactly the same. So what is happening here? Why don't we get the same result when we drop the saturation down to 0? The reason for this is the difference between brightness, lightness, value, luminance, and we need to understand those differences, those terms, to be able to achieve exactly the results we want when we simply want to play with the saturation. So this is the image, this is the value of this image, this is the lightness of this image, and that's the luminance. The differences are noticeable, right? But let's make it a little bit more obvious by taking a look at something like this. Those are just the primary colors. Every of those colors has at least one channel set to 100% and the remaining channels are set to 0. This is red, this is red and green, which gives us yellow. This is green only, green and blue, blue, blue and red. The value of this image looks like this. So we have just a pure white color. This is the lightness, and we see that we have just a half gray. And that's the luminance. And we see the differences between the colors. Let's take a look at the original, and let's take a look at this image and try to say which color is the brightest and which one is the darkest. Well, it feels that this one is brighter than this one. Yellow is brighter than red. Green is brighter than blue. So we perceive those primary colors such that we see differences in brightness. So this, the value, doesn't represent the feeling of the brightness by no means. Lightness as well. But luminance? Oh yes. So this is yellow, and it's the brightest. This is blue, and it's the darkest. And this surely represents our feelings about the brightness of those colors. So luminance is something that we should take care about the most. Especially that human eye is more sensitive to luminance than to the colors. So that's the most important component of the image. Now, what is value? This is just one of the components of HSV, hue saturation value color model. And it in fact doesn't represent anything that is meaningful from our perception point of view. This is just the value of the brightest channel of the red, green and blue channels. That's why this image became pure white all over here, because all of those colors have at least one channel set to 1. So the brightest channel is taken into account and it's passed as the value. Lightness. What is lightness? This is again one of the components of HLS color model, which means hue, lightness, saturation. Lightness is calculated as the average between brightest and the darkest channel. So here, at least one of the channel has the value of 1, and at least one of the channels has the value of 0. So the average is 0.5 for every of those colors. So the lightness of this whole image is 0.5. And the luminance This is described as the sum of the weighted channels. The weights that are used for every single channel depend on the system. So here, YUV system, 0.299 is used for red, 0.587 is used for green, and for blue, 0.114. The same weights are used in YCBCR system with the JPEG option, but here some other weights are used and yet another here. When we use RGB to black and white node, this is also the luminance of some sort, because it's also the sum of the weighted channels, but some other weights are used here. I in most cases use this as the luminance or this, the Y channel from YUV system. And those weights are simply how bright do we perceive 100% of the blue light. This is how bright we perceive 100% of green. And this is our perception of the brightness of 100% of red. So we multiply each channel by its weight and take the sum of those products, and that's the luminance. But wait a minute, what's the brightness anyway? We are talking about lightness, luminance, value, and so on. It all refers to brightness in some ways. And we all remember that we have the node that is called brightness and contrast. Let's drop it here and take a look what happens if we change the brightness. Let's lower the brightness, set it back to 0. Let's increase the brightness. And this is what happens visually, but take a look at the waveform. Brightness, in fact, sets the black point of the image. It's in fact the same as doing this, or doing this. And contrast. What is contrast? Let's increase the contrast. And this is a very simple operation. Anything that is brighter than 0.5 becomes even brighter, and everything that is below 0.5 becomes darker. So that's the contrast. And this is operating somewhere around the midpoint. So that's the naked truth about brightness and contrast. So now let's take a look at another example. And let's play with the saturation. What happens if we pass this image through the hue saturation value node? What happens if we lower the saturation? It's like mixing the original image with the value of this image. If we set the saturation all the way down to 0, we are looking at the value of the image. Here in Blender, we don't have the direct access to the HLS system, hue lightness saturation. So let's take a look at the same image in other application. I will use After Effects, and here we have HLS system. And when I drop the saturation all the way down, I am now looking at the lightness of this image. Playing with saturation here is like mixing the original image with the lightness of this image. But as we learned just a minute ago, desaturating the image using the HLS system also doesn't give you the feeling of not changing the overall brightness. We should use the luminance for that. So in order to desaturate the image, it would be good to mix the original image with the luminance of this image. So we can use converter, separate YUVA, drop it here, and we have the luminance. Now we can use the mix node, take the original, and mix it with the luminance of this image. When we set the factor to 0, we have the full color, and when we increase this factor, we are losing the colors, but don't change the luminance. Or we can replace this node with converter RGB to black and white, and this way we will be using the other weights. So as you can see, it's not that difficult to nicely desaturate the image. But what if we want to boost the saturation? Let's first use the color hue saturation value, connect the image here, take a look at it, and try to boost the saturation. This is what happens. And it's weird because the value is used here. We would like to be able to use the luminance, this luminance or this luminance. Let's use this one. The easiest way to do it would be to swap those images here. So we have the black and white in the upper socket and the colorful in the lower socket. Let's take a look at this. So right now, when we are lowering the factor, our image becomes more black and white. And when we make it higher, all the way to 1, now we are looking at the original image. This is the same. But take a look at what happens when we make this factor higher than 1. This nicely increases the saturation of the image. Let's compare this one to this one. This is even less colorful. Let's boost the saturation a little bit more. And in fact, all the thing that we get is more weird artifacts. But here, I think that it's a lot nicer. So that's the original. That's trying to boost the saturation using the hue saturation value. And that's mixing the black and white version with the original version using the factor that is greater than 1. Now let's take a look at this image. This is the original. This is the boosted saturation in hue saturation value. This is mixing black and white with the original. And this is mixing the luminance from YUV system with the original. Okay, but this was just boosting the saturation or lowering the saturation. Let me now show you the approach to color correction that some of the artists use. This approach is sometimes used by someone who works with TV materials, where even though user interface shows us that we are adjusting red, green and blue channels, we are in fact working on luminance and chrominance. This approach is to set the luminance first and then adjust the colors without changing the luminance. If we use the color balance and try to adjust the colors using the lift gamma gain, we are changing not only the chrominance, but also influence the luminance, because no weights are used when those colors are mixed in. So what we can do about it? Let's delete this node, add a new one. This way I didn't have to reset all those colors one by one. Now let's add the converter separate YUVA, connect it here to the original image. Let's duplicate this node and also separate the changed version. So here we have the luminance and chrominance of the changed image, and here we have the luminance and chrominance of the original. And we can combine YUVA and take the luminance of the original, but chrominance, meaning U and V, from the changed one. This now is exactly the same as the original because we didn't change anything in this node. But now let's take a look at the result and try to change those colors. I will make some extreme changes, but as you can see, no matter what I do, the feeling of the brightness doesn't change, even if I move those sliders. So that's the result of all of those changes. This is the original image. This is the color balance alone, where the feeling of the brightness changed. And this is the result of something that I call preserve luminance. The luminance of this one is exactly the same as the luminance of this one, but the colors changed. We can also try to use another system, not YUV, or try to use the luminance from RGB to black and white. I will delete all of those nodes, connect the original image to this one, RGB to black and white, and I will also duplicate this and connect the changed version to this. So that's the luminance of the original, that's the luminance of this one. So we may try to do some math, like take the difference between the two and add it to the result. So I will use the math node and subtract the changed luminance from the original luminance. That's the difference. Let's now, simply to be sure that we are doing everything correctly, make an image based on this value. So I will combine RGBA, drop it here, and connect this one to all of the 3 channels, and add this to this one. So I will use color mix node, change the blending mode to add, take this and add this one here. And that's what I get. I am changing the colors here, and the luminance that is basing on this model doesn't change. Let's check if it's true. I will take the result of all of those operations and convert it to black and white. And that's the result. And let's take a look at the black and white version of the original image. And as you can see, they are exactly the same. Just to be sure, let's use the color mix, change the blending mode to difference. And if the result of plugging this one and this one here is completely black, it means that there is no difference. Let's take a look. No difference. 0 all over the picture. Okay, let's delete those 2 nodes, take a look at the results, and we have the system that preserves the luminance based on the weights used here. So that's all in this episode. We learned what is the difference between brightness, lightness, luminance, value, chrominance, saturation. We know how to adjust the colors preserving the luminance. Give it a try. Maybe you will like it more than using standard color correction techniques.